Let's walk through an example of how we would select a four-door sedan based on price, mileage, comfort, and safety. I've compiled information about 9 different options so that we can apply both non-compensatory and compensatory methods to figure out which of these cars is our preferred option. First, I want to point out that the safety is identical for all of these options. They all have 5-star safety ratings. Because one of our principles for decision making is that we want to consider the differences only between projects, we can drop safety as a criterion. Next, we want to identify what's the best value for each one. On price, we want to minimize that. So our minimum value is our $20,250 Honda Civic. For mileage, we want to maximize that quantity. And so again, the Civic is the best option. And then for comfort, we've rated each one on a scale from 1 to 10. This is totally subjective, but in my ratings, I have a 9 assigned to the BMW 3 Series sedan, and that's the most comfortable option. Now we want to normalize the values for each criterion so that they range from 0 to 1. To do this, we'll use the same method shown in the previous video. Once we've done that, we can now see that on each of the 3 criterion, we have values for each car ranging from 0 to 1, where 0 represents the worst option and 1 the best option for that particular criterion. Now that we've normalized the value for each criterion, it's easier for us to identify dominated options that we should eliminate from consideration going forward. I recommend normalizing before assessing dominance and eliminating certain options. Keep in mind that this can mathematically change your preferred winner in some cases, and I'll show you in a moment why. All of the options that are highlighted here in red are dominated by at least one other car. The Toyota Camry is dominated by the Mazda 6, and the others are all dominated by the Honda Civic. So we'll get rid of these and condense our options to a smaller table of 5 cars left. Here's where we can see why normalizing before removing dominated options might have an impact on our decision-making process. When we look at the criteria values for mileage and comfort, we can see that our values no longer range from 0 to 1 because the options that had a value of 0 were dominated and now they've been removed. If we were to rescale our options from 0 to 1 using only these 5 cars, you can see that that would change the relative value for a certain criterion compared to the price index, which is unchanged. So now, once we apply our weights, we could potentially have a different shuffling of our order in the weighted linear sum because of the fact that these values for comfort and mileage are larger than they would be if we rescaled them to go from 0 to 1. We talked in the previous video about how to calculate a set of weights for each criterion, so let's use the values that we came up with in that video. Now we have a weight of 0.5 on price, 0.2 on mileage, and 0.3 on comfort. And for each one of these cars, we can now calculate our weighted linear sum by taking the product of the price and its weight, mileage and its weight, comfort and its weight, and then adding them all together. Because our decision rule is to select the car with the largest weighted linear sum, this indicates to us that the Honda Civic is the car that we should purchase. Well then, here we are. That's it. It's the last material for the semester. Kick your feet up. Let your hair down. Celebrate. And hopefully I will see you on Monday morning for the exam review. And they said we need quarantine haircuts. Please.